I'm audible. Hello, 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 hello. Okay. So very good evening, one and all. Today we discuss least square approximations. In the least square approximation function are recovered here. F of x from the given approximation xk. That is f of xk, a is equal to 0.23n. So this job will define the given data. So what is the data of the function? F of x is equal, what is the function? F of x is equal to f of x comma c0 comma c1. అంటే c అంటే విలువలు వచ్చిన టోటల్ నెంబర్ వాల్యూస్ c1 అంటే మనం వాటిని టాలీ చేస్తాం. c1 x అంటే వాటిని స్క్వేర్ చేస్తాం. where c0 c1 cn are certain parameters of which f is dependent. So therefore, f of x is I choose that it is a difference linearly on these interesting parameters. We can recognize this formula. F of x is equal to c0 phi naught x plus c1 phi naught phi 1 x plus into phi 2x and so any valuable number of values set is there and we will మనం ఇక్కడ రాసుకోవడం జరుగుతుంది c and phi x. So therefore, summation of I is equal to 0 c I phi x. So the total value is summation of we are removing the summation. We can write that c naught phi 1 x and c2 phi naught phi 2x. So we are doing the expansion of that value. So phi is also called coordinate the functions so chosen here are selected beforehand. So for example, to take that set of monomers phi r phi dash phi x is equal to x for I phi x for I is equal to I is equal to 0 1 so it's 1 8. So some trigonometric functions on sin phi by phi I x here the combination of it. So normally we are using the any student to be significantly large order, the information about a power can be represented by a proper choice of parameters. So the series C0, C1 and Cn. But however, taken less than the data points in, if any small is out of the reproduction, the errors we are taking here. So we think that the right form of the function of that one, one assumed with the function of n plus 1 we are taking here. There is the parameters, the particular values of determining the order to good approximation. That is f of x is equal to x, capital X, c naught, c1, and so on, cn. The general idea to determine here is that the deviation of t. What is it? T is f of x, xk minus f of x. So see here, I am writing here. So this is f of xk, this is f of x. So these two value minus that is f of x comma minus. So f of x, that's my value I am writing f of k minus c0, c1, c2, cn I am writing here. So therefore again f of xk, then f of xk I am writing here this one, f of xk minus this is summation of ca, ka. So this expansion will be written as k is equal to I1 to n, I is equal to 1 to 3 and so on here I am taking here. So therefore, are simultaneously made in a small part. Minimization of leakage at several ways. The point of minimize of the deviations by making the sum of the magnitudes of the deviations is made. But if you want unbiased results, you cannot use the as a basis of for equal. And you can take the alternative also. Then you can take the alternative also. Then you can take the alternative also. You can make so alternatively, you can make magnitude of the maximum deviation of minimum. So there is a minimum maximum criterion we are taking the magnitude maximum to deviation minimum. So there is the absolute value of the function. We have no derivative and the amounts of no derivative and amounts of the derivative are taken. So the origin and its amounts giving the importance of single origin. The criterion is rejected. Why? How it's rejected is sufficient condition to know that such methods are available for simultaneously minimizing the deviations of the defect. To achieve this desired minimization, once you can try make some norm of n plus 1 vector, but the vector being d equal to d0, d1, dn and power of t is a small possible. The amounts to minimizing modulus of d is a function of c0, c1 and c3 and so on. Cn is the nevertheless customary to choose the second. The more we are taking that modulus of d to the summation of k equal to 0 to k, for summation of k is equal to 0 to n, dk square whole power n by 2. So minimize it since the function is square. The square root clause మనం చేసుకోవచ్చు. So we minimize the d square instead of d2. The result approximation f of x C0, C1, C2, Cn carried out the choice of this norm equation 4. This is called the least approximation given data. The approximations are mostly commonly used for the approximating the f the values which given in a tabular form known explicitly over a given domain. The formal definition of the approximation can be given here. What is the definition of the approximation? So the best approximation is the least squares. Since is defined as that which of the functions here is equal to 1, 2, 3, 4, and n is 9. So the aggregate wx means that weight function wx is equal to dk square is equal to over the given domain is small function. This function wx is then 0. All the weight function is usually chosen as equal to 1 here. So deviation of normal equations. In order to avoid this symbol with the notations here, the derivatives, the deviations are denoted by e instead of in place of we are writing e. For a function whose values are given the dominant n plus 1, x0, x1, and so on, xn we can take here. Here I am taking here f c0, c1, cn, summation of k is equal to 0, n, w, xk. So the weight function here, that is I am writing summation of xk is equal to summation of I equal to 0 to n, ci phi a of xk. So ci phi a of xk, and that is simplify your value. Summation of I is a ci phi a x1, ci phi a x2, ci phi a xn, all are also and the one. This is called as minimum. So therefore, alternatively, the say b is given explicitly we have f of c0 c1 in the integration of a to b wx. It is the minimum is w equal to k0 to n. Here also alternatively minimum here f of x, that is k function here in the f of x minus summation of I equal to 0, ci by a k whole square dx. This is also x. Who choose the coordinate function of I of x? Nominals here. The indicated earlier phi of x is equal to x power I equal to 0, 1, 2 here. So in this section we are weight function of x is equal to 1. Then the necessary condition is c0, c1, cn to have minimum values is that dou e dou c j is equal to 0, 1, 2. These equations are system of n plus 1 linear equations. N plus 1 and c0, c1, cn. These equations are called normal equations. So the normal equation is discrete set of values of these one. So see here all of you, these equations are normal equations. So the vector E is equal to E1, E2, so on, E n whole power t. That is we are writing Ek is equal to, we are taking the constant function here, Ek is equal to fk minus f x comma xk c star for every belongs to k is equal to 0, 1 to n. Where c star is equal to c1, c2, cn whole power t should be normal or orthogonal to each n vectors. Phi 1 is equal to phi 1 xy, phi 1 phi I x naught, phi 1 x1 and phi I x2, and so on phi x and whole power t I is equal to 0, 1 to n we are taking it. As well as sigma k is equal to 0 then f of x comma k minus summation of I is equal to 0 ci phi x k phi x comma dx is equal to 0. We get the j the value is taking to 0, 1 to n we are taking here for these functions. So continuous on a comma b within brackets. These equations are given here integration of it to b lower bound a and upper bound b. F of x minus summation of I is equal to 0 and ci phi x. Right, close I phi j x is equal to 1 to n. This is the ninth equation. So we are solving the one by one solving. So f of x is 0, c so on, c n here is not chosen as a linear function. Why? Because one given equation, but in the form of f of x is equal to c0 x power c1 we are taking here. The normal equation of x shall not be linear c0 and c1. This case will not be dealt within the D 4.3. Derivation of normal equation, the straight line and coordinate for a discrete data. Least squares approximation by first degree polynomial. What is the first degree polynomial? F of x is equal to c0 c1x plus b a first degree polynomial. Approximation of the function f of x of the data. So therefore we are taking c0 c1 two values we are taking here. C0 c1 summation of k is equal to 0 to n f of x comma k minus c0 plus c1 6k whole square, that is minimum. Why these normal equations are below? I am doing the partial derivation here. Dou e by dou c0 is equal, the partial derivation should be minus here, minus summation of k is equal to 0 to n to f of x comma 2x comma 2 f of x comma k c0 plus c1 xk is equal to 0. Dou e by dou c1, second derivation also minus summation of k is equal to 0 to 2 f of xk minus c0 c1 plus c1 xk. So in the first derivation that c0 and c1 xk is additionally taken here. These equations upon simplification reduce to, so C0 n plus 1 plus C1 k is equal to 0 to n x k, C k naught 0 is equal to f of x. C naught summation of k is equal to 0 to n x k plus C1 summation of k is 0 to n x k square. So therefore summation of until then simplify is constant value తీసుకొస్తున్నాం అక్కడ xk x2 is constant value తీసుకొచ్చి దాని value summation of k is equal to n xk f of k. Xk constant out of summation of k is equal to 0 to n f of x comma k. These are the normal equations for the least square approximation by the first degree. So least square approximation by second degree polynomial. We consider f of x C0, C1x, C2x square as the second degree polynomial quadratic or parabolic approximation, the function f of x of the data. So must have C0, C1, C2, summation of k is equal to 0 to f of xk minus C0 plus C1 xk plus C2 xk square whole square, that is minimum. The normal equations then become dou e by dou C0 is equal to minus summation of k is equal to 0 to n 2 f of xk minus C0 C1 xk plus C2 x square is equal to 0. Dou e by dou C1 minus summation of, already I told that C1 and C2 also minus summation of k is equal to 0 to n 2 f of xk minus C0 C1 xk plus C2 xk square plus xk. The same third partial derivation dou e by dou C2 minus summation of k is equal to 0 to n minus 2 into f of xk minus C1 xk C2 x2 x square k. So in the first derivation, what you have C2 x square k, but in the second partial dou e by dou C1 C1 x xk plus C2 xk into xk. In the second derivation also x square. So upon simplification, these equations should be reduced to here C0 n plus 1 plus C1 xk plus C2 summation of x square. That is summation of f of xk. C0 summation of xk that I am writing in the summation of xk plus C1 constant 1, taking the common summation of x square k plus constant to summation of x cube is equal to summation of xk is constant, then f of xk. Then C0 summation of x square k plus C1 summation of x cube k plus C2 summation of xk summation of x square k into f of xk. These equations are called as the normal equations corresponding to the least square approximation by second degree polynomial of this sphere. This procedure can be generalized and stated in the form of algorithm. So what is the algorithm of the discrete data? Read the approximate function, identify the parameters and the coordinate functions. Go to the set of normal equations in general form corresponding to the number of parameters in step 1. Use the tabular form to the required sums in the normal equations. Substitute the sum evaluated in step 3 in the normal equations 2. Solving the resulting normal equations. Obtaining the values in the parameters. These values substituting the parameters approximating the function least square approximation. So what is the continuous functions we are taking? Read the approximate function, identify the parameters correct. Use the equation number 6. What is the equation 6? See here all of it. This is the V C0 C1 Cn integration way to be weight function of Ws C0 C1 n. That is the function I am taking in here. This one I am taking here. So far C0 C1 Cn, the derivation of dou e by dou C naught is equal to 0, dou e by dou C1 is equal to 0, dou e by dou C is a partial derivation. What I am doing here. So evaluate the integrals and simplify them to get them n linear equations and parameters. Solve the system of equations to get the values C0, C1, C2, Cn. Substitute the values of C, the approximate function to get the required approximation. It's obtain the least square of obtain the values here. If we take one example here, find the least square approximation by first degree polynomial to the data. Given the data is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. F of x is equal to 0, 0.6, 1.77, 1.92, 3.31, 3.52, 4.59, 5.31, 5.79, 1.7.06, and 7.7. What they got the least approximation they are asking. In this problem, xn is equal to n is equal to 1 to 11. In the problem, x is equal to small x is equal to given 11 numbers. Since the approximation is done in the first degree polynomial. What's the formula? F of x, x is C0, C1, C0 plus C1x So the number of parameters is equal to n, then the coordinate of coordinates. The functions 5 x is equal to 1, 5 x is equal to x. So the equation of the normal equations of the desired polynomials are, see here the desired polynomial, what is the desired polynomials here? What is the total numbers is 11. See here, I am just again telling you, this is 11 here. So I am writing 11 0. Total 1, 2, 3, 6, 10, 15, 21, 28, 36, 36, 45, 55, 66. So it's 11, 66.0. So I'm totaling 0.6 plus 1.77, 1.92, 3.31, 3.52, 4.51, 5.31, 5.79, 7. These total are total 41.04. You can carry. So 41.04. Then again we go to the 66 C0. 66 means what is the 66? So 66 means we have to see here. I am again on the way 60. 1 square 1, 2 square 4, 3 square 9, 4 square 16, 5 square 25, 6 square 36, 7 square 49, 64, 8 is 64, 9 9 is 81, 100, 100 and 121. So these are the values of this one. So these all these multiplying, that is 10,000 1 plus 4, 5 plus all these are, we can calculate here. These values are 60. So what's 5 not 6? 5 not 6 means 0 square, 0.6 square, 1.77 square, 1.9, 1.92 square, 3.31 square, 3.52 square, 4.59 square, 5.31 square, 5.79 square, 7.06 square, 7. All these totals are 328. I'm solving these two equations. 11 is 0 plus 661, 66 is 0, 5 not 6. I'm solving these two equations that we are getting the value. C0 is equal to 0. Minus 0.7314, 7 is equal to 0.743. So I'm solving the two equations. When the required f of x equal C0 is equal to minus 0.7314 plus 0.7434. C0 plus C1 values I'm writing here. We can take another example. We can take another example too here. Find the least square approximation by second degree polynomial. Minus 2, minus 1, 0, 1, 2, 15, 1, 1, 3, 9, 2. In this sample, the total numbers is given 5. So the approximation is second degree polynomial x equals C0, C1, C2, C0 plus C1x plus C2 x square. So double that given that in the above problem only, in the above problem given x f of x is given, but they are asking the second degree polynomial. So we are getting C0 plus C1x plus C2 x square. So I am explaining here for your understanding. Here there is a minus 2, 1, 2, 0, 2. Again I am drawing that one. This I am writing xi minus 2, 0, 1, 2. What's the given value? 15. Minus 2 plus 1, minus 2 plus 1, 3. 2 plus 1, that the value is 0. There is a 15, 16, 17, 20, 39. They given that 39 here. Again we go to the problem. So 16, 17, 17, 20, 39 I am writing here. Xi of 5 here. So xi of 5 here multiply. 15 into 2 minus 30. Minus 1 into 1 minus 1. 0, 1, 0. 1 into 3, 3. 2 9 is 38. So I am removing this one. Xi square. What is xi square? 2 squares of 4. Minus 1 squares of 1. 0 square is 0. 1 square 1. So the total is 4, 8. 8 plus 4, 1, 5. 5 and 10. Here also you can, you have to calculate here. So xi value 2 into minus 15, 30. So minus 38 is 41. 41 minus 31. 41 minus 31, that's the value is 30. So what is that should be done? Then xi square and xi. Xi square. What is xi square here? What is xi square here? 4. F5, 4 into 15. 60. 1 in this is square. Xi square 1. Xi square 1 into 1 1. Then there is a 0 automatically. Xi square means 1. 1 into 3, 3. Then automatically 30, xi square 4, 4 is 16. 16 into 19, f of xi. Xi square is equal to, I'm sorry, the 4 into xi square is equal to xi square is equal 4 into 19, that is 76. So this is the values here. We are writing. Then xi cube also we can write here. Cube means -8, -1 means xi cube we are writing here. Xi cube -1 whole square, this is -1, see here. This is 0, 1 square 1, 2 square 8, 8 plus 1 9. This is 8 minus -8 minus 1 value is 0. Given values is correct here. Then xi 4 I am taking here. Xi power 4. 4 2 4 the 16. 1 4 the 1. 0 1 1 the 2 for the 16. So this is 16 plus 1 17 the 34 I am taking here. The least approximation. Using this table above equation, the desired approximation here. So 5C0 total values is I am writing here and we write 5C0 plus total values is 10C2 here. 2 plus 1, 2 square means 2 square, 1 square, 5. 2 square, 1 square, 5. 5 5 is 10. 10C2 is equal to, that is the value is 10. So set my 5x again. Then 10C1 is equal to 10. I am writing the system of equation. And 10C0, what is 10C0 here? 2 square and 1 square, that is 10C0. And 14C2 also we can multiply with squares here. 4 plus 14 into 2 square, 8 plus 1. So that is the value is 14C2. That is the output is 14C2. That is the 140. So we are calculating C0 minus 37 by 15. C2 is equal to 30 by 7. We are writing that f of x is equal to 1 by 35 and also minus 37 or 35 less than 56. That is easy. In a linear polynomial approximation, f of x cube on the interval 0, 1 using the least approximation. Consider a polynomial f of x equals c0 plus c1 x where c0, c1 are arbitrary parameters. Using the equation w of x by function, we are writing here e c0 is an integration of 0, 1 formula x cube. We are taking the three polynomials here x cube minus c0 plus c1 x over 2 dx is minimum. So first I am deriving dou e by dou square x square means 2x, 2 is the constant here, x cube minus c0 plus c1 dx is equal to 0. 2x కాబట్టి రాసేసుకుంటాం. ఇది మొత్తం x గా తీసుకుంటాం. We are treating as the total as x square dx I am writing. Then dou is c1. So 2 of 1 to 0 x cube minus c0 c1 x. So this is again the partial derivation is constant is x dx is equal to 0. After evaluating this integrals of the two equations we get, I am applying the values here. I am applying the values of two values here. So for 1 I am applying 1 minus 0, that is totally 1 plus c1 is equal to 1 by 2. And again the denominator all the values applying c0 plus 2 by 3 c by 3 by 5. So I am using solving two equation 2c0 minus c0 is equal to 2 by 3 c1 minus c1, the value should be c0 to minus 1 by c1 equal to 9 by 10. So the linear polynomial is minus 1 by 5 plus 9x by 10. It is a simplification of 1 by 10 into 9x by 10. So we can take another equation also here. Obtain the least square polynomial approximation of 2 degree f of x is equal to over 1 by 0 1. It is equal to f of x c0 plus c1x plus c2x square c0 c1 c2 or three parameters not found to be found. Sorry, from equation 6 also the weight function already I told you c0 c1 c2 integration of 0 1 x power 1 by 2 minus c0 plus c1x plus c2x square whole square dx is equal to 0. The normal equations are also I am telling here. Dou e by dou c naught is equal to integration of 1 to 0 x power 1 by 2 minus c0 minus c1x minus c2x square dx. So we are derivating c1 minus 2 x power 1 by 2 minus 0 minus c into x dx into x square. The part in the without c naught లో మనం x రాయమక్కడ dx రాస్తాం c1 లో రాసినప్పుడు x d into x dx. On the simplification of these three values c0 plus 1 by 2 c1 plus 1 by 3 c2 equal to 2 by 3 1 by 2 c naught and 1 by 3 c1 plus 1 by 4 c2 equal to 2 by 5 and 1 by 3 0 1 by 4 c1 1 by 7 equal to 2 by 7. So the solution c0 c1 c2 we are writing here. This is the solution of that. So under this one also same example showing you how to do here. So same method. So advantages and the limitations of the least approximation. What is the advantages? You are affiliated with the probability distribution measures the dispersion in statistics. Dispersion in statistics, you should upgrade the method in according to the first order to maximum likelihood principle. If the measurement error follow a normal distribution and if the standard deviation is a constant of all the data, the line determined by the dimension sum of the squares can be to have the values to the scope and shift to the maximum likelihood of accuracy. This method also gives a unique result of the given data. What is the limitations for? What is the limitations? If the linear system of normal equations ended in five, the phase as to the phase and added difficult solving them because such a system undesirable property known as ill conditioning. The result of that, the round of errors we are taking, we are solving the cause unequally or just in the C0, C1, C2, etc. So why ill condition of normal equation? These are advisable to take coordinate functions as some as orthogonal. And such popular technique is that modified Graham-Schmidt. This is the Graham-Schmidt orthogonalization process from the point of view of experiment the complex and the fourth degree polynomials. Satisfactory least square approximation of the number of data points is not adequate by small allocated interpretation error. There should be at least twice number of arbitrary constant to be determined in the approximation. So weighted residuals, weighted normal equation. What is the residual method? Discussing the method of least square approximation f and division, leaving the deriving the normal equations here. The right hand side we are deriving the consequence square of the derivative dk. Multiplied function, the weight of function a wx is called the function. This product as over and summed over. The values of x is the given data is discrete integrate over on b. In the domain of x is the function is continuous. But it means we have chosen that the weight of x w of x is equal to 1 illustrate the least square approximation. For some things may happen that all the deviates of residue should not be the same. This is the case of especially when we use the residual of function of 1 instead of 1. For example, if there is a situation should be more useful the residuals of log y instead of those of 1. This is done that achieve the greater accuracy in the computation 1 and 2. The sum deviation to positive signs, negative signs the sum of total all deviations. You can take that y is equal to alpha p power n here we take that v1 equal alpha p power n minus 1 alpha p2 power n by 2. The deviation choose as d1 dash equal to log of alpha plus n log p1 log yn d2 dash equal to log alpha. See here when you got the derivations figure all of you. This is n log p1, this is log p2, this is log yn. The other remaining values are the same here. You can take here. Again, shown that in the deviations normal weight is possible to introduce the idea of y term observation. So weight of an observation we are taking. By the weight of an observation, the relevant value or import when compared with other observations. Thus, if you measure a line 3 times with the same care and accuracy, you can regard the mean of these measurements as more reliable one of the single mean. This is expressed by saying that the weight of the mean of 3 times is a lot of single measurement. What is the measurement we are taking the observation the weight for W only, which is the equivalent importance of observation. When we are taking the residuals at different weights, we shall not discuss the procedure for weighting the normal equations. Weighted normal equation. The best value of unknown quantity, can be obtained from set of measurements of unequal precision is some weighted squares of residual mean. Hence, one sum must have summation of W experiments, weight of x equal to d1 square, d2 square, d2 square, and as well as we can take here Wn d square, we can call it as a minimum. For example, in the case of y is equal to a plus bx plus cx square, you have take here W1, a plus bx plus c1 x1 square minus 1. So 3x1 plus bx1 cube we are taking here. So there's W2, a plus bx which is cx2 square minus y2 square, plus W3, a bx plus 3 plus cx plus 3 minus y3 whole square and so on. We are taking this is minimum value you can take. Okay. So taking this expression f of a comma b comma c and the value with respect to the ABC in term and equity each to 0, dou by dou 2w1 a plus bx1 x2 minus 1 plus 2 into derivation I am taking here. So 2 in front of that. So I am taking that. See here. See, this is I am taking here x square. But the chain rule x square means 2x. 2 into a plus bx is x square minus this is also same. 2 into w to a into b. Then again I am derivating by b 2 into w1 x1. So this is a plus bx1 plus x1 square minus 1. So I am taking this x1 function. This is x2. Then third one x square, x1 square and x2 square also. Dividing these equations and taking here through the by 2 obtain w1 plus a1 plus bx1 plus c1 square y1 plus w2 a plus bx2 plus c2 square y2 plus wn a plus bx1 plus c square minus y is equal to. So therefore we are writing here w1 x1 a1 a plus bx1 plus c1 square minus 1 w2 x2 a plus bx2 plus c square y2 plus wn x and a bx1 c square y2 x1 square also writing equations. This is the above equation called as weighted normal equation. The curve y is equal to a plus bx y plus a plus bx plus c square. This is the normal equation. So we can write here a summation of wi plus b summation of wi plus x plus c summation of wx square. That is writing summation of y. A summation of wx plus b summation of wx plus c summation of wx plus that is writing c summation of wx. A summation constant I am taking the common here. A summation of wx square constant common again. B summation of wx cube, c summation of wx square, c summation of wx square y. So step 1 on the algorithm we are also taking the steps here. The first weighted normal equation multiplying the residual expression weight and the coefficient of the first unknown that equation. Add the product to obtain the adequate of sum of the zero here. Write the second weighted normal equation by multiplying the right number of each residue of application by its weight and the coefficient of the second unknown that number. Add the products and obtain the equate the summation and continue this procedure and continue this procedure to get the rest of the weighted normal equations. These weighted normal equations are solved using the theory of determinants grammar rule. The parameters of these the required formula obtained by the numerical values of normal values. Now denote the weights y and fi. Y and w are respectively the residuals of log x to fi. So we see the w is to w by the dash of y. F of log y log 10 point is to log the very equal log is the log 10 point where the y is equal to 0.34 and the dash y is equal to equal y then w by hence here w is equal y square. The actual computation of numerical problems is the square equation here. The equation 15 and 16. Ignore the some problems here. Then can do some problems here. Consider the same problem in the rate of flow from a fire hose, which is proportional to same power of pressure with mass. 94, 118, 147, 180, 230, 10, 16, 128, 46. So F we are taking 1 copy from again log of F is equal to formula log L log alpha and log P. You can write as F is equal to A plus NP. A is equal to log alpha, P is equal to log. I'm applying I plus NP formula here. A summation of WI into summation of WI to A equals summation of WI. Right? A constant, summation of WI to A and into summation of WI to A square and that. So what the values written here? 1. What's the P value here? What the P value means? Log. What is the log P? What's the P? What is the P here? What's the P? What's the P taking here? So the P taking here pressure of P. The pressure of the log 10 and the log 60. Again, log 25, log 40, log 60. I'm writing the values here. What's the log values here? So you have to check F also same. F also same taking a log. F also log F. Log f value I'm writing here, this is f value is writing. W is equal to f square, 1.97 into 31, 1.97 into 31, I am doing here. So that is a 3.8931236. 2.7019, 4.2927696. 2.173 square is equal to 4.69711892. 2.2553, 5.086378, 2.3617, 5.577. W multi W is 3.8931236 into 1. Same 1236. Same one. I am WP. W W to P. So 4.29276936 into 1.2041. The value is 5.168923. Then W 4.697189 to 1.397. And 5.086378 into 1.6029. Then 5.566 to 1.79. So these are W into F. Now WP again, WF. What is W? 3.8931236 into 1.973. 5.1689238 into 2.0719. 6.56 2.007 into 2.1673. 8.14 sorry 4.697118 into 2.1673. 5.0680863780 into 2.2553. 5.50068 2.361. So these values are summation of W, summation of WP, I am written here. So these values after written here, then P square. What is the P square? 1 square, 1. Then again 1.20141 into 1.204. And 1.3979, 1.379, 1.6031 into same, 1.77 into these values. WP square. W is equal to what is the P square? What is the P square value here? WP square 3.89, 3.8931236. So this W is equal to this I am writing 3.0, then 5.238. So the 1 into multiply the same. So 1 into P square means 1. W is equal to P square. So W into P square means 1. So P square value of W what is the W is 4.2972696 into 1.4499. So under W, we are multiplying W the P square value is 6.2240866. And also again third one 4.69711892 into 1.9541. 5.086378 into 2.5667. 5.5776268 into this one. Then again we are doing the same P of F. What is P of F? What is P of F? What is P? This is my P of F. 1.9 so 7.6. This is W of F. 7.6 not P of F. W of F. We are writing here. W of F 7.68. These values are written. So after that WP square. WP square 25 point I'm calculating and writing the values. The solution is A value and N value. Additional approximation. Approximational functions are a discrete data beyond. So the polynomials is always this method, especially when the function behaves a rational function. So the least square approximations can be replaced as rational approximation functions. The efficiency of any numerical method is usually measured by the computer. Time required for that. The second consideration of the storage here requirement for the arithmetic operations of the computer can directly evaluate the polynomials. As such, you will learn in this section about rational approximation as an efficient approximation to rational function, which are two polynomials but obtaining the truly best rational approximation. As the required successful approximation of the suitably closed initial approximation. So learn in the section only elementary method finding rational approximation. Hopefully this study shall introduce the procedures, ideals, and here. When the function f is that reaches finite value x infinity polynomial approximation, this is a very poor result in comparison. Rational approximation gives much better results. The preference, the rational approximation, rational function, the numerator is the same as that the denominator. The rest of the empirical fact that the errors are usually less or such. The rational approximation. The rational approximation of f of x is written in the form for n minus n comma x a0 a1x plus a n x n plus b0 A is B0, B0, B1 x plus Bn x. Where the suffix I'm taking here, n comma m. So or n comma include the number of numerator and denominator of degree and respective. Constant denominator, the constant denominator term is always taken as unity without loss of generality, even if it is B0. Convert to this form, dividing the numerator and denominator by constant B0 is a denominator should not generally equal 0, else the approximation becomes undefined x equal. These approximations are not only used for application function, but also apply the functions that may have like the order of accuracy, at least the same can be achieved by using lower degree polynomials than the directed polynomial. The additional approximation given by equation is popularly known as pad approximation. Most useful of the pad approximations is the degree of the numerator. So R1 greater than R. So till the pad approximation, the Claren series f of x summation of these will be written Cj xj x power j C0 C1 x plus C2 x square C3 x3 x1 Cn xn x power n, where Cj known constants Cj is equal to f power j0 by j factorial. So that is done, we can write here f of x r n minus x is summation of j0 is equal to infinity Cj xj minus a0 plus a1 x so on n xn 1 plus b1 xn so on plus b1 x. So we are writing the values C0 plus C1 x plus C2 x and so on Cn xn 1 plus b1 plus xn so on plus bm xn minus a0 plus a1 x so on am xn by 1 plus b1 xn plus bm xn. N is equal to n plus n. You can observe here the total number of constant R and mx is equal to n plus 1 a0 a1 a2 an b1 b2 bn are determined imposing the conditions here that the f of x and the first n equal to n plus n derivative f of x must be equal to R and mx, and the n derivatives R and m, the respect to x is equal to. For example, f of x is equal to R and mx, x is equal to 0. The numerator has no cost C0 minus A0 is equal to 0. Why? Because we are taking the n derivative of x R n minus mx equal to 0. The coefficient of the powers is x up to including x power n, so equal to 0. These will be given n additional equations. So first involve A and the latter involve only B and C here. So we are writing the format equation from C0 plus C1 minus A1 is equal to 0. B2 C0 plus B1 C1 minus C2 minus A2. B2 then B3 with B3 C0 B2 C1 B1 C2. The equation is expanding. B4 C0 B4 C0 then B4 C0 will come automatically. Then B3 B2 B1 and the C3 minus C2. A3 comes automatically from here. And the nth condition Bm minus Cn minus 1 plus Bm minus Cn minus 1 plus 1 plus Cn minus n equal to 0. Bm Cn minus 1 plus 1 plus Bm minus 1 plus Cn minus 2 and so on Cn plus 1. Bm Cn minus 1 Bm minus 1 Cn minus plus 1 plus Cn is equal to 0. It is easy to realize that the sum of the subscripts on the factors of each product is the same and the equal to the exponent of the x term. The numerator, for example, the second equation, the set of equation is obtained equating the coefficient of x square to 0. Hence, the sum of the subscripts to each two also to these endless equations, the required coefficients of the approximation here. Note here that the first non-zero term, the numerator is the approximation. This process is now symmetrized here under 2. Write the Maclaurin series expansion of this certain number of terms. Choose and fix the rational approximation suitable between the numerators and denominator. Equate the coefficient of variance powers x in the numerator to 0, get the required number of equations like those solve the obtained equations A and B. Substitute the obtained value of A and B to get the desired approximation, and obtain the rational approximation for x the form of a0 plus a1x a2 x square plus 1 plus b1. Using a polynomial of degree 5 in the numerator, approximate the value of tan inverse x or equal to 9 using the rational approximation that is padded and take condition taking here and telling here for your this problem. The Maclaurin series after tan inverse of x to x power 9 here. So therefore, x power 9 means we can write here tan inverse x is equal x minus a 1 by x cube, 1 by 3 x cube, 1 by 5 x by 5, 1 by 7. We are writing odd numbers 1, 3, 5, 7, 9. That is 1 by 3 x cube, 5 x by 5. Odd numbers are negative. 3 is negative, 5 is positive, 7 is negative, 9 is positive. So taking that one f of x r minus 9. So here 1 by x cube, that's the above equation I'm writing, and above writing the formula a0 plus a1x and so on plus a1x by 1 plus b1x b2x plus b3x 3 plus b4x. So the above equation writing, the LCM I'm taking here. LCM of 1 plus b, 1 plus b1x b2x plus b3x bx 4 minus c0 a1x plus a5 x5 by 1 plus b1x plus bx plus b3x. So this is only one term. That is not division of 1. It's only one term. This is a division of this by 1. So I'm writing here. So what we can determine n plus 1 is equal 5 plus 4 plus 1 from the above equation we are writing here. So totally 10 by I x power I is equal to 0, 1 to 9. So therefore b is equal to 0. Minus a is equal to 0. 1 by a minus 9 is equal to 1. b1 minus a2 is equal to a2 is equal to b1. Minus 1 by 3 plus b2 minus a3 is equal to b2 minus 1 by 3. All the values I am substituting here. 1 by b minus 3, b plus b3 a minus 2 is equal to 0. Therefore is equal to b3 minus b1 by 3. 1 by 5 minus 1 by 3 b2 plus b4 minus a5 is equal to 0. a5 is equal to 1 by 5 minus 1 by 3 b2 plus b4. 1 by 5 b1 minus 1 by 3 b3 is equal to 0. So all the values I am solving these equations, and the b1 is equal to 0, b2 is equal to 10 by 9, b3 is equal to 0, b4 is equal to 5 by 21. So substituting these values, b1 is equal to 0. So these values, a1 is equal to 0, a1 is equal to 1, a2 is equal to 0, a3 is equal to 7 by 9. These values come here applying in the tan. So after the tan inverse applying x plus 7 by 9, x cube 64 by 9, 45, x power 5, 1 plus 10 by 9 x square, 9, 5 by 21 x power 4 and 9. So now compare the error of the approximation here. Maclaurin series computing the values is of 0.2, 0.4, 0.6, 0.8, the following data table as per the x tan inverse x and we're taking the tabulated value and the Maclaurin series value and the error value, additional approximate value error also taking. So we can observe that this tabular value is equal to 0.08 and 1. The error in the Maclaurin series are sizable. The ratio approximation is almost accurate. The 0.8 into 10 power minus 2. Error estimation in ratio approximation. We compare the error for a approximation to the Maclaurin series expansion listed in table. You see that the error later approximation in the consider x is 0.6, 0.8 size of x equal to 1. The limit of the convergence of the series, however, there is a 5 decimal precision x is equal to 0.2 and 0.4 can be seen. The error approximation is surprisingly accurate with the maximum 1 by 275 x equal to 1. The approximation of the function can be estimated solely of an f0 term the numerator f of x minus rn minus n comma mx. So this is involved in the constant. And I did that when the error was estimated here. So therefore, in the form of a relational function, the actual error point of x in the domain can be substituting the value x in the form of relation. Usually, it may happen that the estimated error shall be wrong, as can be seen from the problem of the earlier, especially when the coefficients are not decreased. Let us demonstrate this one today. We can see that this one values are they are writing this one. This is the values of this one. So this is the least approximation you have learned today. Now I am going to the another topic. System of linear equation. Gauss-Jordan elimination method, Jacobian Gauss-Seidel integration method, convergence integration for integration method, and the conditionalized system inverse of the matrix. So what is the inverse of the matrix? So you can learn the several situations in physics and engineering. You know that Ax is equal to 0, modulus of A is equal to 0. So therefore, in inverse of the matrix, we have X is equal to inverse B. All the problems and equations are the system of linear equations. Find the inverse and over. The direct adjoint method finding the inverse of the matrix has become tedious. So therefore, numerical method provide an approximate. So after this unit we can studying x is equal to inverse B inverse and non-singular matrix A. Learn the following methods. That is in a direct method, namely Gauss' Jordan elimination, Jacob inverse method, and Gauss-Seidel method also will eliminate here in this unit. So in this unit we learn these problems here. So what is Gauss-Jordan method solving this system? What is a Gauss-Jordan? The Gauss Jordan has the equation here. The equation consider system of n-law and algebraic equations here. A1 x1, A2 12 x2, and so on. 1 n xn is equal to v1. A21 x2, A22 x2, and so on. A21 x2, an1 xn, an2 xn, an xn. So aij, and I means row and j is column. J is 1 in the coefficient bii is 1 into 1 into n. The known as values as determine the matrix notation. The written as a1, a11, a22, a 21, 22. We are writing row columns. First equation 11, 22, 23, 1, 21, 22, 23, 20, 31, 33, 30, 3, an1, n2, n. So what is the system of linear equations? Side values given 1, 2, 3, 4, getting x1. The values are b1, b2. So simply x is equal to b, we can write here. The elementary n matrix A is called coefficient matrix. Elementary a one column matrix X is called solution vector B. If B is an n into one column matrix, all B is 0, then the system is homogeneous here. If at least B is non-zero, the system is called inhomogeneous. The homogeneous system X is equal to 0 possesses a trivial solution X is equal to x1, x3 is equal to, and so on, xn is equal to 0, modulus of not equal to 0, possesses infinite number of non-trivial solutions, modulus of E is equal to 0. But the homogeneous system of the unit solution modulus is not equal in such a case that you can write x is equal to inverse B. In order to solve the system of equations, there's some direct methods. The familiar method is called Jordan elimination method. So the elimination elements will be virginal, diagonal, 8, 11, 800, 8, and the coefficient of matrix is 0, while at the same time zeros are created to the man. When this process, the diagonal elements are equal unity, the coefficient of matrix finally transforms into diagonal. When this is accomplished, the column matrix on the right hand side shall be transformed into the solution vector on the completion of the Gauss Jordan method. So already I told you, suppose 1, 2, 3, 4, 3, 4, 5, 6, 7, 5, 6, 7, 8, 9, 10, 11, 12, 13. So what is finally R3 minus R2, R2 minus R1, and R3 is on 1, 0, 0, 0, 1, 0, 0, 0, 1. Which is a matrix size. So 1, 3 cross 3, x1, x2, x3, and x up to xn, c1, c2, cn. So on the solution, and the given xi is equal to ci, I is equal to 1, and this is called the Jordan method, ABIC. So for reducing here, the coefficient of matrix, identity matrix, we apply the elementary column operations also. Interchange of below interchange of elementary of 2 rows or 2 columns, even columns not to be 2 or to be 2 multiplication of any rows of non-zero constants, multiplying row column by number and number to మనం first column third column eliminate చేయడానికి తీసేయడానికి suppose third column లో 5 ఉంది, first column లో 10 ఉంది, third column లో 2 into 2 చేస్తే first column third column లో value eliminate అయిపోతుంది. The validity of these operations are independently obvious. We think them being applied to set of linear. Multiply them, any equation brought out by non-zero constant does not change to the equality. Similarly, and in the equality quantities the rules and equality. Therefore, obviously, the ordering of the set of equations arbitrary. These operations which do not change the relationship between by set of equations can be applied the argument of matrices by different operation of equations. The 11 H1, so an and b1, 21, 20, and b2, and 20 a and 1 and 2. The equation, the system of linear equation also values మనం రాస్తాం. Elementary row operation is enlisted, denoted by Ri, the ith and jth row. The operation is enlisted. Kri is ith row multiplied by the non-zero constant. Similarly, operation is denoted by H, Ri plus Rg, the ith row is multiplied by constant H, and there is resultant and the ith. Corresponding 3 operations are applied here. Columns and figures Cj, K, Ci, Ci plus Cj respectively may be denoted that you can apply the operations of the columns, operation of time and the matrix, but cannot apply some operations here. The column operations of the matrices simultaneously. It should be noted in a given matrix. What is 5? During the process of reduction of A to Y, at a normal matrix, 1, 0, 0, 0, 1, 0, 0, 0, 1. Sometimes after that may be created diagonal positions, if they are not present in the virginal coefficient matrix. So what's 0 here? The leading diagonal interchanges already. But here in the 3 equations, the coefficient of large magnitude in the diagonal. The strategy known as practical poverty assumes a non-zero diagonal exists. it has added advantage in the improved document precision. The building diagonal elements in the coefficient matrix are called power elements. So therefore, we can do these pivot elements with it. అంటే ఈ row జోడ ఎలిమినేషన్ లో మనం రోస్ కాలమ్స్ మార్చుకోవచ్చు, కాలమ్ మార్చుకోవచ్చు, మల్టిప్లికేషన్ చేసుకోవచ్చు, డివిజన్ చేసుకోవచ్చు. దాన్ని బట్టి మనం ఐ మ్యాట్రిక్స్ తీసుకోవాలి. ఈ ప్రాబ్లం అనేది మనం ఒకసారి చూద్దాం. Consider the system of equation 3x minus y squared is 2 picture over it. Diagonally dominant. So what is the given there? See here, 3x minus x2 plus 2x plus 3 1, x plus 1 2x2 minus x minus 3, 2x minus x2 plus 3x3 equal to. What is to put the coefficient of the large magnitude of the diagonal step? Sometimes you have to go the complete file in this process. You shall not apply interchange the equations, but also interchange the position of the variables. But this is not frequently required, and now you can have the algorithm for the card over. Argument matrix M into n column is B. So n into n plus 1 matrix also you can take it. Apply the n into n plus 1 augmented matrix. Partial pivoting is necessary to the value element first row the column of the natural matrix. Create zeros in the second row, and the rows is the first column by substituting a n by 11 time of first row and next row. Repeat step in second and third for rest of the rows and columns, and see that at the conclusion of these steps, the coefficient of matrix A, the augmented matrix, and M into n matrix. Read that. అంటే మనం వచ్చిన వాల్యూస్ మనం స్టెప్ 3 లో జీరో చేసుకుంటూ ఎంత వచ్చిన ఫస్ట్ కాలం సబ్ట్రాక్ట్ am by ai1 by a11 times the first row to the ith row తీసుకుంటాం. Read the values of the n plus 1 to the column transform the augmented matrix. These values are given x1 x2 directly with the values of solution. For the system of linear equations problem, we will see the problem tomorrow. This one. So thank you, Varun.